There is no object, there are no walls, there is only a gear, bronze, corroded, astonishing in its complexity, sitting inside a lump of limestone pulled from the bottom of the Aegean Sea. It contains 37 interlocking gears, a differential mechanism, and a display system capable of predicting lunar eclipses. It was made in the 1st century BCE. The earliest comparable mechanical device we know of appeared 1400 years later. Today we examine 7 discoveries, separated by oceans, millennia, and civilizations that never exchanged a single word, that share the same impossible problem. They exist. We are not talking about anomalies that resist explanation at the margins. We are talking about objects and structures and bodies of knowledge so technically precise, so mechanically sophisticated, so far beyond the tools and materials available at the moment of their creation, that the explanations we have constructed around them require more assumptions than the mysteries themselves. 7 discoveries, 5 continents, thousands of years apart, and the same question stated differently each time, but never answered. Let us begin. The air inside the Antikythera Rex site, 84 meters below the surface of the Aegean, is cold in the way that only deep water can be cold. Not the cold of weather, but the cold of pressure, of permanence, of time that does not move. In 1900, a group of Greek sponge divers anchored near the small island of Antikythera during a storm. One of them, Elias Stadiatis, descended in a diving suit and resurfaced pale, here reporting what he described as a pile of decomposing horses and naked women on the seafloor. What he had found was a Roman-era shipwreck, dated to approximately 70 to 60 BCE. Among the cargo, encrusted in limestone and coral, was a fragment of corroded bronze that nobody paid serious attention to for decades. The Antikythera mechanism, as it came to be known, was formally studied by the historian Derek de Solla Price of Yale University, beginning in 1951. Price spent decades analyzing the fragments, publishing his definitive analysis in 1974 in the journal Scientific American. What he described changed the way scholars understand ancient technology and created a problem that has never been fully resolved. The mechanism contains at minimum 30 gears. Though researchers using modern imaging technology, including a 2006 study published in Nature by Mike Edmonds and Tony Freeth of Cardiff University using 3-dimensional X-ray tomography, have identified fragments suggesting the original device contained more than 37 individual gear wheels. The gears mesh with a precision that requires manufacturing tolerances of less than half a millimeter. The device tracks the Metonic cycle, a 235-month lunar calendar, and the Saros cycle, which predicts eclipses with sufficient accuracy that modern astronomers still use a version of the same calculation. It contains a differential gear mechanism, a component that allows 2 outputs to be driven from one input while running at different speeds. In modern engineering, the differential gear is considered a fundamental mechanical innovation. We did not reinvent it until the 16th century CE. The official archaeological position is that the Antikythera mechanism represents the pinnacle of a tradition of Greek mechanical engineering that has simply not survived in other physical artifacts. This explanation is coherent. The ancient Greeks produced sophisticated works of mechanical philosophy. Archimedes described theoretical machines of considerable complexity. It is entirely plausible that craftsmen of the Hellenistic period, working in metal workshop traditions we cannot fully reconstruct, achieved a level of precision that exceeded what we assumed possible. The problem is not the mechanism's existence, the problem is its isolation. In 1900, when Stadiatis surfaced with his report of horses and naked women, there was no other known artifact from the ancient world that contained a differential gear. In 2024, after more than a century of archaeological investigation of Mediterranean sites, Roman ports, Greek foundries, and Hellenistic metal workshops, there is still no other known artifact from the ancient world that contains a differential gear. Not a fragment, not a partial assembly, not a tool that could have produced one. The mechanism did not evolve in front of us. It appeared fully formed in a cargo hold and then vanished again as a tradition. What was built between the Antikythera mechanism and the next comparable device, a gap of 14 centuries that no longer exists. Now let us leave the cold floor of the Aegean and move east across 3,000 kilometers to the Saqqara Plateau in Egypt, where the air is not cold but pressing, thick with calcium dust and the particular stillness of spaces that have not been disturbed in 3 millennia. The corridor descends below the desert surface at a slight angle. The limestone walls are close enough that 2 people walking side by side must turn their shoulders. And at the end of this corridor, in chambers cut directly from the bedrock, are the boxes. The Saqqara Serapeum was rediscovered in 1851 by the French Egyptologist Auguste Mariette, who had followed a lead from Strabo, the ancient Greek geographer who had written about an avenue of sphinxes leading to a buried temple dedicated to the god Serapis. A Mariette excavated for months through drifting sand and found the underground galleries, and inside them 24 enormous granite and limestone sarcophagi positioned in side chambers along the main corridor. Each sarcophagus is cut from a single block of Aswan granite. The external dimensions average approximately 3.85 meters in length, 2.3 meters in width, and 2.7 meters in height. Each one weighs between 70 and 100 tons, with the granite lids alone weighing an average of 27 tons. The internal surfaces, the floor, walls, and ceiling of the box, are polished to a flatness that engineer and researcher Christopher Dunn measured in his study published in 2010 at tolerances of less than 0.02 of an inch, approximately 0.05 millimeters. To put that in concrete terms, that is the manufacturing tolerance of a precision optical flat, the kind of surface used in modern metrology laboratories to calibrate measurement equipment. It is the surface you need when you are making something that has to be exactly right. Egyptologists generally interpret the Serapeum as a burial complex for the Apis bulls, sacred animals associated with the god Ptah, later syncretized with Osiris and Serapis. The sarcophagi on this reading were ceremonial containers for mummified bulls, and their high degree of finish reflects the religious importance of the ritual context. This interpretation is supported by inscriptions on some of the boxes and by the presence of votive objects in several chambers. The problem with this explanation is not theological, it is logistical and mechanical. The largest of the Serapeum sarcophagi weigh 100 tons. The corridors through which they were transported to reach their current positions average approximately 2.5 meters in width, barely enough clearance for the boxes themselves, with almost no room for the mechanical systems that would be required to move them. Engineer Franz Luhner, who conducted a formal mechanical analysis of granite transport in the context of pyramid construction, calculated that moving a 100-ton object through a 2.5-meter corridor would require eliminating virtually all conventional options. Ramps are too steep, rollers require lateral space that does not exist, and rope and pulley systems have nowhere to anchor. Beyond the question of transport, the internal polish requires a level of abrasive and mechanical consistency that archaeologists have not been able to replicate using period-appropriate tools in demonstrations. In 2019, a team at the Institut National du Patrimoine in Paris attempted to polish a section of Aswan granite using copper tools and abrasive sand. The result, after 40 hours of work, was visually smooth but measured at tolerances 300 times coarser than the Serapeum boxes. How do you move a 100-ton box into a corridor that has no room to move it, and then polish its inside walls to the precision of a calibration instrument? The silence inside those granite chambers is not empty. It is a question that weighs 100 tons, and has been waiting 23 centuries for an answer. If you arrived here and you are not yet following the channel, well, this is the moment to do it. What comes next is the kind of investigation that most people prefer not to look at too closely. Now let us cross the Atlantic 25 centuries back and 6,000 kilometers west to the Colombian Andes, where the light is different, sharper, thinner, arriving at angles that make gold glow in ways that have no equivalent in temperate climates. In 1969, the Gold Museum in Bogotá, the Museo del Oro, catalogued a collection of pre-Columbian Quimbaya artifacts that had been in the museum's possession since 1969, having been acquired from a burial site in the Cauca region of Colombia. Among the zoomorphic gold figurines, stylized animals worked in tumbaga, a gold-copper alloy used throughout pre-Columbian goldsmithing, researchers identified approximately 30 small objects that did not clearly resemble any known animal. The Quimbaya treasure gold figurines, dated to approximately 500 to 800 CE, are small. Most measure between 5 and 9 centimeters in length. The objects in question, sometimes referred to in the literature as the Quimbaya aircraft figurines, feature a vertical stabilizer, delta wings, a fuselage with a pronounced nose, and aerodynamic surfaces. In 1994, aeronautical engineers Algund Inboom and Peter Belting, working in Germany, constructed scaled-up models of the figurines using balsa wood and lightweight materials, fitted them with small engines and flew them. The models flew stably and demonstrated aerodynamic properties consistent with a modern fixed-wing aircraft configuration, specifically resembling a delta wing design with characteristics similar to the Concorde's planform. The academic interpretation is that the figurines represent stylized fish or insects, specifically a type of flying fish known from Caribbean and Pacific coastal waters, or large flying beetles. This is a reasonable starting position. The Quimbaya were sophisticated goldsmiths with deep knowledge of the natural world, and artistic stylization of animal forms frequently produces shapes that differ from strict naturalism. The aeronautical counter-argument is specific. In 2010, researchers at the Aeronautical University of Embry-Riddle in Florida compared the geometric proportions of 17 of the figurines with known zoological specimens, flying fish from the genus Exocoetus and large beetles from the order Coleoptera. The comparison found that the figurines' vertical stabilizers, the dorsal fin equivalent, are positioned asymmetrically relative to the horizontal plane in a way that does not match any known fish or insect anatomy, but is consistent with aircraft design requirement for yaw stability. Flying fish do not have upturned tail fins. Beetles do not have delta wings with swept leading edges. The shapes, when analyzed as aerodynamic objects, function. When analyzed as zoological representations, they require unusual assumptions about which features were stylized and which were preserved. Or something was observed that we have not accounted for, or an artist's hand produced a functional aerodynamic form by a route we cannot reconstruct. Choose which answer requires more assumptions. The stone is not remarkable from a distance. It sits in a museum case in Baghdad, or it did before 1991. What remains of the original collection survives in photographs and in the records of the German archaeologist Wilhelm König, who excavated at the site of Qujut Rabua, near the modern city of Ctesiphon in Iraq, between 1936 and 1938. König found a ceramic jar approximately 14 centimeters tall, sealed with an asphalt plug with a copper cylinder inside and an iron rod at the center of the cylinder. He recognized immediately what he was looking at, or what it appeared to be, and published his interpretation in 1940. The object became known as the Baghdad Battery. The Baghdad Battery, there are actually several similar objects, with the most complete example measuring 13.5 centimeters, dates to the Parthian period in Mesopotamia, approximately 250 BCE to 640 CE, though Koenig argued for a date closer to 200 BCE. The electrochemical properties of the assembly are straightforward. Copper and iron, separated by an electrolyte, produce a galvanic cell. Willard Gray, a researcher at the General Electric High Voltage Laboratory in Pittsfield, Massachusetts, demonstrated this in 1940, filling a replica with grape juice, a period-plausible electrolyte, and measuring a voltage output of approximately 1.5 to 2 volts. In 1978, Joanna Egerbrecht of the Roma Pelizaeus Museum in Hildesheim replicated the experiment and used the current to electroplate a small silver statuette with gold, a process he proposed as the intended use of the original devices. The mainstream archaeological consensus holds that the object was most likely a storage vessel for papyrus scrolls or a container for organic materials, and that the combination of copper, iron, and acidic residue found inside, possibly from fermented grape or date juice, is coincidental rather than intentional. This interpretation is supported by the absence of any other electrical technology in the archaeological record from the same period. No wiring, no lights, no described application that would require electrical current. The counter-argument is symmetrical. If the electrochemical properties are coincidental, then a craftsman working in the 3rd or 2nd century BCE happened to assemble from a sealed ceramic vessel an asphalt plug, a copper cylinder, and an iron rod, a configuration that modern electrochemists recognize as a complete galvanic cell without meaning to. The probability of that coincidence is not impossible, but the jar produces current. Not metaphorically, not approximately. It produces approximately the same current as a modern 1.5 volt AA battery, and it does so with materials that were available and a configuration that is not random. What were they powering? Precision of measurement in the 3rd century BCE without instruments of metal, a mathematical system so sophisticated it wouldn't be reinvented in the West until the 17th century CE. Let us now travel to the subcontinent, to the banks of the Godavari River in Maharashtra, India, where a different kind of impossibility has been waiting in a manuscript. The Bakshali manuscript was found in 1881 by a farmer near the village of Bakshali in what is now the Khyber Pakhtunkhwa province of Pakistan. The farmer discovered the manuscript while digging in a field. It was buried, folded into a bundle of birch bark sheets. The manuscript eventually reached the Bodleian Library at Oxford University, where it has been held since 1902. In 2017, a radiocarbon dating study conducted by the Bodleian, the first systematic dating of the manuscript's individual folios, produced a result that upended the existing scholarly timeline. The Bakshali manuscript contains the oldest known written record of the symbol for zero, not zero as a placeholder concept, which had existed in various forms in Babylonian and Maya mathematics, but zero as a number, a quantity, an integer, an entity that can be operated upon mathematically. The concept of zero as a number, not merely an absence, is the foundation of the positional number system that underlies all modern mathematics and computing. Without operational zero, calculus, as Newton and Leibniz formulated it, cannot be written. Binary code cannot be expressed. Modern cryptography cannot function. The 2017 radiocarbon dating study found that the Bakshali manuscript's oldest folios date to between 224 and 383 CE. The accepted earlier scholarly estimate had placed the manuscript at approximately 800 to 1200 CE. But this means the document predates the previously accepted origin of zero as an operational number by at least 4 centuries. The scholarly response was careful. The radiocarbon date applies to the physical material of the manuscript, not necessarily to the mathematical content recorded on it. It is possible, and several researchers, including Kim Plofker of Union College, have argued that the manuscript represents a later copy of earlier mathematical material, and that the birch bark simply happens to be older than the text written on it. This is a legitimate methodological concern. The counter-argument is also legitimate. If the mathematical content of the Bakhshali manuscript is as old as its oldest physical material suggests, 3rd or 4th century CE, then the operational concept of zero was fully developed in South Asia at least 400 years before historians had believed. If the content is later than the material, then someone in the 7th or 8th century CE was copying mathematics onto birch bark that was already 300 years old. Neither explanation is simple, and the zero, regardless of its precise origin date, enabled everything that followed it in mathematics, physics, and computation without anyone alive today fully understanding the chain of minds through which it emerged. What else did those minds know that no longer has a manuscript to survive in? If that question, a sophisticated mathematical concept appearing centuries before its supposed origin, feels like an isolated anomaly, wait until you see what we find next. The pattern we are tracing becomes harder to attribute to coincidence with every case. The precision required to achieve what we are about to examine was not approximated. It was not attempted and partially achieved. It was executed in granite with a consistency that modern engineers consider extraordinary, and then it was not done again in any recorded culture for the following 2,000 years. We are in Puma Punku now, at an altitude of 3,800 meters above sea level on the Bolivian Altiplano, 18 kilometers east of Lake Titicaca, in the ruins of a ceremonial complex associated with the Tiwanaku culture. Well, the wind here is constant and carries the particular bite of high-altitude cold, the kind that arrives at the joints before it reaches the skin. The stones on the ground around you are not recognizable as ruins in the conventional sense. They are scattered, enormous, and when you look at their edges, something is wrong. Puma Punku is dated by archaeologists primarily through ceramic stratigraphy and associated organic materials. A 1985 study by John Colata and Oswaldo Rivera, published in the Journal of Field Archaeology, placed the initial construction of the Tiwanaku complex at approximately 300 CE, with Puma Punku's primary construction phase occurring between approximately 600 and 900 CE. The Tiwanaku people had no known writing system and no metal tools harder than bronze. The H-blocks of Puma Punku, so named for their characteristic cross-sectional shape, are cut from red sandstone and andesite. The andesite blocks, some of which weigh up to 130 tons, were transported from a quarry near Lake Titicaca, approximately 90 kilometers from the site. The sandstone blocks were quarried approximately 10 kilometers away. Both materials present the same problem: their cut surfaces. Archaeometrist Alexei Vranich of the University of California, Berkeley, conducted surface analysis of the Puma Punku H blocks and measured the interior angles of the carved recesses at consistent 90-degree precision. The recesses, channels, slots, and joining surfaces repeat with dimensional consistency across blocks that were clearly produced separately. In other words, multiple blocks were manufactured to tolerances that allow them to interlock precisely with blocks they were never fitted to before assembly. This is the principle of interchangeable parts, the manufacturing concept that drove the Industrial Revolution in the 18th century. The official interpretation is that the Tiwanaku people, working with stone and bronze tools over many generations, achieved a high level of craft skill through accumulated practical knowledge, and that the scale and precision of Puma Punku, while impressive, falls within the range of what determined human effort with period-appropriate tools can produce. This position has support. Experimental archaeology has demonstrated that bronze chisels can produce surprisingly precise cuts in sandstone under controlled conditions. And that a culture with sufficient organizational capacity and time can achieve monumental construction without advanced metallurgy. The counter-argument focuses on the combination of factors rather than any single element. The transport of 130-ton andesite blocks 90 kilometers across terrain with no wheeled vehicles and no draft animals capable of pulling that weight. Llamas, the largest domesticated animal in the Andes, have a maximum load capacity of approximately 40 kilograms. The cutting precision achievable with bronze tools on andesite, a stone harder than bronze itself, rated 7 on the Mohs hardness scale, which means bronze tools simply cannot cut it without rapid tool destruction. A 2003 experiment by archaeologist Patrick Nunn attempted to replicate Puma Punku-style cuts in andesite using bronze tools. The results showed significant tool degradation and surface inconsistency within the first hour of work. Nossos ancestrais fizeram isso, not the ancestors of one people, the ancestors of all of us. Bronze tools cut stone harder than bronze. A culture with no writing left behind interchangeable parts. 90 kilometers, no wheels, no animals strong enough to pull it. What are we missing about what they knew? We have one final case, and it is perhaps the most quietly devastating, not because of its size or its mechanical complexity, but because of what it implies about the limits of what we are willing to accept as knowledge. The Valley of the Whales, Wadi al-Hitan, lies in the western desert of Egypt, approximately 150 kilometers southwest of Cairo, in what is today a remote and inhospitable stretch of sand and wind-eroded limestone. When paleontologist Philip Gingerich of the University of Michigan first conducted systematic excavation in the area in the 1980s, he found something that geologists had suspected since the 19th century, but had never fully mapped. The valley floor is covered in the fossilized remains of ancient whales, specifically Basilosaurus and Dorudon, dating to the Eocene epoch, approximately 37 to 40 million years ago. This is expected. The Western Desert was once a shallow sea. What is not expected, and what has nothing to do with the whales, is the astronomical alignment at the megalithic site discovered in 1998 at a location approximately 100 kilometers south of Wadi al-Hitan, near a dry lake bed called Nabta Playa in the Nubian desert close to the Sudanese border. The site was identified by archaeoastronomers Fred Wendorf and J. McKim Malville, whose analysis was published in Nature in 1998. What they found was a stone circle, 6 megalithic slabs, and several smaller stones arranged in a pattern that dates through thermoluminescence dating of associated ceramics and organic materials to approximately 6,000 to 6,500 years before the present. That places it at around 4,000 to 4,500 BCE. The Nabta Playa stone circle is 4 to 5 centuries older than Stonehenge. It is older than the earliest phase of Egyptian dynastic culture, and it is astronomically aligned. The 2 pairs of slabs within the circle are aligned to the summer solstice sunrise. The larger megaliths outside the circle, some weighing more than a ton, standing upright and arranged in lines radiating outward from the central circle, align to the meridian transits of the stars Sirius, Dubhe, and the Belt of Orion as they appeared in the sky approximately 6,000 years ago. This was determined by McKim Malville through precession calculations, accounting for the slow wobble of the Earth's axis that shifts star positions over millennia, and confirmed independently by Thomas Brophy of the University of Colorado in his 2002 analysis published in the journal Mediterranean Archaeology and Archaeometry. The mainstream interpretation is that the builders of Nabta Playa were nomadic cattle herders, cultures that have been documented in the region through rock art and ceramic evidence, who had a sophisticated practical knowledge of celestial cycles because their pastoral migrations depended on seasonal and astronomical timing. This is a well-supported and entirely reasonable explanation. The alignment of megalithic structures to solstice and stellar positions does not require writing, metallurgy, or institutional science. It requires observation and the capacity to record what you observe in stone. The scale of what was observed, however, requires attention. To align standing stones to the meridian transit of specific stars as they appeared 6,000 years ago, accounting for precession, requires understanding the concept of axial precession. The complete precessional cycle takes approximately 25,772 years. The ancient Greeks credited Hipparchus with discovering precession in approximately 127 BCE. The builders of Nabta Playa aligned their stones to precessional star positions roughly 3,900 years before Hipparchus was born. Either they discovered something about the sky that we attributed for millennia to the Greeks, or the alignment is coincidental and Brophy's mathematics are wrong, which Malville's independent calculations do not support, or there is a third path, that the knowledge of how the stars move across centuries was available to people who had no institutions, no universities, no written record, and that it has mostly not survived because the medium through which it was transmitted was not stone. The medium was memory, and memory does not survive. 7 discoveries, 5 continents, a gap of 40,000 years from the earliest evidence of astronomical observation to the latest mechanical artifact we examined today. In each case, there is an official explanation. In each case, the official explanation is reasonable, carefully constructed, and supported by real evidence. And in each case, the same problem presents itself. The explanation accounts for the existence of the artifact or the knowledge, but not for its isolation, not for the silence before it and after it, not for the absence of the tradition that should surround it, the tools that should have produced it, the failures that should precede every success. What we are accumulating here is not a series of anomalies, it is a pattern of absences. Every one of these discoveries sits alone in its period, like a sentence without a paragraph, coherent in itself, but disconnected from the text that should surround it. The Antikythera mechanism without a mechanical tradition, the Serapeum without comparable stoneworking, the Nabta Playa alignment without a documented astronomical school. 7 moments where someone knew something or made something that the record around them does not explain. There are 2 ways to hold this pattern, and neither is entirely comfortable. The first is that our archaeological record is catastrophically incomplete, that for every object that survived, 10,000 did not, and that the traditions we believe were absent simply have not yet been found. This is methodologically sound. Archaeology is, by its nature, the study of what survived destruction. The Library of Alexandria, burned in 48 BCE during Julius Caesar's occupation of the city, contained an estimated 400,000 to 700,000 scrolls, the single greatest repository of ancient knowledge we know of. What was in those scrolls is not known. What cannot be reconstructed, because it was not copied before the fire, is also not known. We are working from the ashes of the record, not the record itself. The second is that human cognitive capacity, the biological machinery of observation, abstraction, and problem-solving, did not change meaningfully between 40,000 years ago and today, and that the gap between ancient capability and modern technology is a gap of accumulated cultural transmission, not a gap of raw intellectual capacity. On this reading, isolated individuals or small groups throughout history solved problems that the surrounding culture was not equipped to preserve, and those solutions disappeared with the people who held them. Not suppressed, not hidden, simply not transmitted. Both of these possibilities leave the same residue, a question that the evidence itself seems to be asking. It quietly, through the precision of a polished surface, the alignment of a standing stone, and the interlocking teeth of a gear that should not exist. What did we know before we forgot how to keep it?